There's no sign of one. Or is there? Its wobble hints at something sloshing inside. Could this frozen cue ball be hiding a secret sea? Speaking of oceans, let's talk about Europa. From the outside, smooth, icy, calm, but beneath that icy shell lies a vast liquid ocean, possibly twice the volume of all of Earth's combined. And where there's water, there could be life. But this isn't just water, it's salty, warm, and restless, stirred by tidal heat. Think about it, a world with no sunlight, no air, and yet the potential for alien microbes swimming beneath a frozen sky. But Europa isn't alone. Its cousin Enceladus is a snow-white jewel orbiting Saturn, and it sprays water into space. That's right, massive plumes erupt from its south pole, launching ice and vapor hundreds of kilometers into the void. NASA flew a spacecraft through the spray and found organic molecules, hydrogen, salts, the ingredients for life, on a tiny moon no wider than Arizona. Something is cooking under that ice. Then there's Phobos, Mars' largest moon, but large is generous. It's irregular, potato-shaped. It orbits Mars so fast, just 7 hours, that it rises in the west and sets in the east, and it's spiraling inward. One day, Phobos will get too close, break apart, and form a ring around Mars. This isn't science fiction, it's orbital destiny. Now shift your eyes to Titan, Saturn's heavyweight moon, bigger than Mercury, shrouded in a thick orange atmosphere, not of oxygen, of nitrogen and methane. It rains liquid methane. Rivers of hydrocarbons snake across its surface. Lakes, seas, even waves. But it's minus 290 degrees Fahrenheit, cold enough to freeze steel. Yet it has weather, seasons, climate. It's the only place in the solar system, besides Earth, known to have standing bodies of liquid. It's alien, but eerily familiar. Let's get weirder. Iapetus, another Saturnian enigma. Half of it is dark as charcoal. The other half is bright as snow. A world split in two. And there's a ridge running along its equator. A mountain range that wraps around the moon like a belt. Where did it come from? No one knows. It looks like a walnut from space. A cosmic oddball with no clear origin story. Now zoom out, way out, to Uranus. Its moon Miranda is a shattered world stitched back together. Cliffs 20 kilometers tall, the tallest in the solar system. Canyons, ridges, and terrain that looks like it was cut and pasted together by an indecisive god. It's as if the moon broke apart, and gravity pulled it back into a Frankenstein shape. A patchwork of chaos orbiting a tilted, icy giant. And finally, the wild card, Pan. Not even spherical, it looks like a ravioli, a literal space ravioli. Why? Because it orbits inside Saturn's rings and has scooped up material around its equator. That ring of debris formed a bulge, a ridge, a pasta-shaped moon that clears a gap in the rings like a tiny cosmic Roomba. Small, bizarre, and totally unique. This is just a glimpse, a glance at the celestial zoo that orbits our planets. These moons aren't just rocks. They're laboratories. They're time capsules. Some are active, some are dead. Some could host alien life. Others are ticking time bombs. They challenge everything we thought we knew about what a moon could be. We often look at planets as the rulers of their orbits, the undisputed sovereigns of the solar system. But these moons, they're the revolutionaries. They don't follow the rules, they rewrite them. Some moons have atmospheres thicker than Mercury's, others have none at all, yet still host violent geological activity. Some are ancient and cratered, bearing the scars of billions of years of cosmic history. Others have surfaces so fresh, so smooth, it's as if they were born yesterday. These aren't static worlds, they evolve. They change. They surprise us. Take the way many of them interact with magnetospheres. For example, Ganymede, Jupiter's largest moon, is not only bigger than Mercury, it's the only moon in the solar system with its own magnetic field. A moon with a magnetic shield. That means auroras, glowing curtains of light, dancing across its icy crust, shaped by the giant planet it orbits. A moon with its own space weather. And let's not forget that some of these moons may not be moons forever. Their orbits decay, their surfaces erode. Some are being stripped apart by radiation. Others may one day escape their planets entirely, set adrift into the void as rogue objects, cosmic loners, bearing the chemical fingerprints of the systems they once called home. Some moons act like engines, driving the structure of the ring systems around their planets. Shepherd moons like Prometheus and Pandora don't just orbit Saturn, they sculpt its rings, gravitationally herding ice and dust like sheepdogs of the cosmos. Without these moons, Saturn's iconic rings would be chaos. And in a twist of poetic beauty, some moons are the products of cataclysm, likely formed from violent impacts in the ancient solar system. Pieces of shattered worlds coalescing into new bodies. Every ridge, every groove etched into their surface is a page in the history book of celestial violence. But perhaps the most humbling realization is this. We used to think of moons as passive companions, but now we see them as active players, architects, disruptors, potential cradles of life. Each one offers clues about habitability, chemistry, heat, time, about the very nature of planets themselves. Look close enough, and a moon becomes a mirror, reflecting not just its planet, but our own endless curiosity. What might we find in the methane lakes of Titan? What strange pressures exist beneath Europa's ice? Could microbes be swimming under Enceladus's crust right now, never knowing a star, a sky, or a sun? They don't need to be large to be important. They don't need to glow to be powerful. These moons whisper to us from the edges of our reach. We're not just followers, we're worlds. And somewhere in those icy oceans, fractured terrains, and volcanic pits, lies a secret the cosmos is still keeping. So the next time you gaze at our moon, bathed in pale silver light, remember, it is but one member of a sprawling, unpredictable lunar family. Out there, orbiting giants of gas and ice, are moons that erupt, moons that freeze, moons that whisper with oceans beneath their shells, and rain hydrocarbons from alien skies. They are not background characters in the solar system's story. They are the plot twists. They challenge the definitions of life, habitability, even of what a world truly is. And they remind us, again and again, that the universe is far weirder, wilder, and more imaginative than we ever dared believe. We searched for planets and found miracles hiding in their shadows. Because in the grand symphony of space, even the moons have something to say, and we are finally learning to listen.
Top 10 Most Extreme Planets Ever Discovered. Our solar system is weird, no doubt about it. We've got a gas giant with 100 moons, a planet that spins sideways, and a rock where it rains sulfuric acid. But once you step outside our little planetary neighborhood and look at the rest of the galaxy, things get truly insane. Because out there, beyond the quiet familiarity of Earth and Mars, lie planets so extreme, so alien, so unimaginable, they shatter everything we thought planets could be. These aren't science fiction worlds. These are real, confirmed by telescopes, sensors, and good old-fashioned math. And they're rewriting the rules of what it means to be a planet. Take HD 189733b, for example. At first glance, it seems like a typical hot Jupiter, a gas giant orbiting insanely close to its star. But get closer, and you'll discover that the skies of this world are unlike anything on Earth. The atmosphere is a thick, toxic brew of silicate particles, that's right, glass, suspended in hurricane-force winds blowing at over 5,400 miles per hour. That's 7 times the speed of sound. And the glass? It's not sitting calmly in clouds. It's raining sideways. Razor-sharp shards of molten glass, cutting across the sky at supersonic speed. If you could stand on a floating platform in the upper atmosphere of HD 189733b, and you absolutely couldn't, it would be like standing inside a diamond-tipped sandblaster cranked to maximum. This planet doesn't just challenge survival. It annihilates the very concept of it. But if you think that's brutal, meet KLT 9b, a planet so hot, it's actively being vaporized by its own star. Orbiting a blue A-type star just 670 light-years away, KLT 9b is the hottest exoplanet ever discovered. Its day-side temperature reaches over 7,800 degrees Fahrenheit, hotter than some stars. At those temperatures, molecules break apart. You don't just lose your atmosphere, you lose chemistry. Even iron and titanium exist here as vapor. The planet is quite literally being boiled away by radiation, its atmosphere escaping into space like steam from a boiling kettle. It circles its star every 36 hours, locked in a deadly embrace, slowly evaporating into the cosmic wind. Then there's WASP 12b, another hot Jupiter, but one that's being devoured by its star. It's so close, it's egg-shaped, stretched by tidal forces that should be illegal in this galaxy. And while it whips around its star every 26 hours, that same star is pulling its atmosphere off in real time, forming a glowing trail of planetary plasma that wraps around the system like a death spiral. Scientists estimate this planet has less than 10 million years left before it's gone. Swallowed. Dissolved. Reduced to stardust. A planet being pulled apart atom by the very force that once gave it light. And then you've got HD 106906b, the rogue outsider. This planet is 11 times the mass of Jupiter, but it orbits its star from 60 billion miles away. That's 2,000 times the distance between Earth and the Sun. It's so far out, it takes nearly 15,000 years to complete a single orbit. We're not even sure how it formed. It's too far away to be born in a regular protoplanetary disk. Some scientists think it was ejected from the inner system in a violent gravitational slingshot, others think it might be captured from another star entirely. In either case, it shouldn't be there. It's a planet on the edge of exile, drifting through the dark, barely bound to its star at all. A cosmic orphan with a loose grip on home. And speaking of wild orbits, buckle up for Kepler 16b. This planet orbits not one, but 2 stars. Yes, a real-life Tatooine, except the physics here are far more mind-bending than Hollywood ever showed us. Kepler 16b orbits its binary stars in a complex, elegant dance. The stars themselves orbit each other, and the planet orbits both, not in chaos, but in perfect resonance. From the surface, if such a surface existed, you'd see 2 suns rising and setting, their combined light casting twin shadows across the terrain. But what really stuns scientists is how stable it is. This wasn't supposed to be possible. For decades, we thought planets couldn't form around binary stars, that the gravity would rip protoplanetary disks to shreds. And yet, Kepler-16b is there. Quiet. Solid. Orbiting in defiance of everything we expected. And now, let's visit GJ504b, a planet that, by all accounts, should still be glowing red with heat. Except, it's pink. Literally pink. This gas giant, 4 times the mass of Jupiter, glows with a strange magenta hue, due to its youth and unusual atmospheric chemistry. It orbits a relatively sun-like star, but far out, about 40 times Earth's distance from the Sun. And here's the kicker, it's only about 160 million years old. Practically a newborn, in cosmic terms. It radiates infrared heat, which makes it visible to special telescopes. But the pink color? That's real. It's the product of methane, low clouds, and possibly silicate hazes. It's a candy-colored gas giant, floating out there like a bubblegum balloon in the dark. If our planets are military-issue survival gear, GJ504b is the glitter-coated unicorn helmet. Ridiculous. Beautiful. And totally real. Let's dive deeper into the madness. You've heard of carbon-based life. Well, how about a carbon-based planet? Welcome to 55 Cancri E, a world that defies belief. Twice the size of Earth and nearly 9 times more massive, this hellish super-Earth sits so close to its star that its year lasts just 18 hours. That's right, a full orbit in less than a day. But the orbit isn't even the craziest part. You see, 55 Cancri E is likely made, at least partially, of pure carbon. Under the immense pressures inside this planet, that carbon may be crystallizing into diamond. A planet, made of diamond. Forget mining asteroids, this world might be the largest gemstone in the galaxy, worth more than every economy in the universe combined. Of course, that glittering idea comes with a catch. The surface temperatures reach over 3,600 degrees Fahrenheit. The day side is hot enough to vaporize metal. Any hopes of landing, or surviving, or even observing it in detail are shattered the moment you get close. It's a furnace wrapped in crystal, a deadly jewel forged in fire. Now brace yourself for Trace 2b, the darkest planet ever discovered. This gas giant reflects less than 1% of the light that hits it. That's darker than coal, darker than black acrylic paint, darker than anything in the natural world. If you were flying past Trace 2b in a spaceship, you wouldn't even see it. It would be a hole in the stars. A ghost. Its atmosphere is likely full of light-absorbing compounds like vaporized sodium and potassium, or possibly exotic elements that haven't been fully identified yet. It doesn't glow. It doesn't reflect. It just swallows light. Scientists believe it may glow faintly red due to its internal heat, like a dying ember, but make no mistake. This is the shadow planet. The closest thing we've found to an invisible world. It lurks like a whisper in the void, unseen but undeniable. And if you like strange, how about a planet that was never supposed to exist at all? Let me introduce you to Gliese 436b, a planet covered in burning ice. You heard that right. Gliese 436b is a Neptune-sized planet, with a surface covered in ice, that's on fire. It orbits so close to its red dwarf star that temperatures on the surface soar above 800 degrees Fahrenheit, and yet, somehow, the water on this planet remains solid. How? The secret is gravity. The planet's massive core exerts such incredible pressure on the water molecules that even at searing temperatures, they stay locked in a crystalline structure known as ice-X, a form of water ice that exists under extreme pressure. And that's not all. The atmosphere is leaking hydrogen into space, creating a glowing comet-like tail that trails behind the planet as it races around its star. Imagine that, a world of superheated ice, steaming in the glow of a nearby star, leaking gases like a living comet. It's a contradiction. A paradox. A middle finger to everything we thought we knew about physics. And if you're looking for epic, nothing compares to J1407b, the planet with rings that put Saturn to shame. We're talking about a ring system 200 times larger than Saturn's. If J1407b were placed in our solar system, its rings would stretch across the sky like a glowing crown, visible to the naked eye. Not just in telescopes, you could literally stand on Earth and see the rings spanning across the night like a second Milky Way. Scientists believe these rings are temporary, part of a massive debris disk left over from moon formation. One day, the rings may collapse into dozens of moons. But for now, they orbit like colossal hula hoops made of dust, rock, and ice, painting cosmic art around this gas giant. We don't have images of J1407b's rings, only data. We've seen their shadows, their transits, their gravity. But the idea that such a world exists is almost mythological. It's like something out of an ancient dream, and yet, it's real. Next up, Kepler 70b, a planet that was supposed to die, but didn't. Once upon a time, its parent star swelled into a red giant, the kind that should have incinerated any nearby planets. But Kepler 70b somehow survived, orbiting just 240,000 kilometers from its star's surface. That's less than the distance from the Earth to the Moon. Surface temperature: around 12,000 degrees Fahrenheit. That's hotter than some stars. The planet may have once been a gas giant, stripped down to its metallic core by the expanding star. Now, what remains is a glowing ember, a dead planet made of metal, circling its star in a death spiral every 5.6 hours. It is one of the hottest planets ever recorded, surviving where no planet should. A skeletal remnant, enduring in the fire of its own apocalypse. And now, we arrive at a planet so bizarre, it breaks not just the rules, but the context for rules entirely. Say hello to TOI 849b, a planet that shouldn't exist, because it's missing something rather important, its atmosphere. This world is roughly the size of Neptune, but unlike Neptune, it doesn't have a thick layer of gas. Instead, it appears to be the exposed core of a gas giant. Imagine a planet once swaddled in clouds and storms, now stripped bare by forces we can only guess at. All that's left is dense rock, metal, and mystery. It's like finding the fossilized skeleton of a Jupiter that never finished forming, or worse, that got torn apart. Was it devoured by its star? Ripped open by a collision? Abandoned by the universe itself? Whatever the cause, TOI 849b is raw, silent, and deeply unsettling. And here's the thing, it's not alone. The more we look into the galaxy, the more extreme worlds we find. Planets that orbit white dwarfs. Planets that orbit 3 stars. Planets made almost entirely of iron. There are lava worlds, plasma storms, glass hurricanes, water giants, and Earth-sized rocks that orbit their stars every 18 hours. There's even OGLE 2016 BLG 1928, a planet we detected without seeing its star at all. We found it through gravitational microlensing, the subtle warping of light as it passed by. A free-floating planet, likely ejected from its solar system, drifting through the galaxy alone. No orbit. No sunrise. No warmth. A planet without a sun. And maybe, a million more like it. The point is this: there is no normal in the universe. When we began hunting exoplanets in the 1990s, we expected to find copies of our solar system. We thought we'd see neat little rows of rocky planets, gas giants, moons, and comets, just like home. But instead, we found chaos, diversity, violence, beauty, and in that beauty, a truth. We are not the rule. We are the exception. Our quiet, balanced, life-nurturing Earth is not typical. It's rare. Maybe even precious. Because out there, planets are forged in fire, hurled into darkness, chewed by stars, shredded by gravity. The cosmos is not gentle. It's creative, yes, but rarely kind. And yet, we keep searching. We peer through telescopes and parse data from distant stars. We send probes to icy moons and point satellites toward the shadows. Not just to find life, but to find perspective. Because these extreme planets, with their shattered orbits, molten surfaces, diamond crusts, and rings the size of solar systems, they show us what's possible. What's real? What's out there? They remind us that the universe doesn't just tolerate weirdness, it runs on it. And they whisper to us, across the void, you've only just begun to understand. There are forces in our universe so powerful, so vast, so utterly beyond our everyday comprehension, that they don't just shape galaxies. They define reality itself. You wake up on Earth, feeling the pull of gravity. Seems gentle enough, right? But what if I told you that this unassuming force is holding entire solar systems together, and ripping others apart in the hearts of black holes? Let's zoom out. Way out. Because today, we're diving into the 6 most powerful forces in the cosmos. And I promise you, they're not just mind-blowing. They're universe-breaking. Let's begin with the fundamental force of gravity. Yeah, that quiet tug keeping your feet on the ground. It's also what caused stars to ignite, planets to form, and galaxies to swirl into elegant spirals. But gravity isn't just a cosmic glue, it's a cosmic sculptor. Collapsing gas into suns. Warping spacetime itself. Near a black hole, gravity goes berserk. Time dilates. Light gets trapped. Matter gets spaghettified. This isn't science fiction. It's Einstein's terrifyingly accurate reality. Now, step into the quantum world, and you'll meet another behemoth, the strong nuclear force. It doesn't act across galaxies. It doesn't even act across atoms. It operates at the heart of matter itself, inside atomic nuclei. Without it, the universe would unravel. Protons would repel each other, atoms would fly apart, and stars wouldn't burn. The strong force binds quarks into protons, protons into atoms, and atoms into you. And me. And everything we've ever known. But the cosmos isn't just built on order, it's built on violence. Enter supernovae, the death cries of massive stars. Imagine a star dozens of times more massive than our sun collapsing in on itself. In one final, cataclysmic moment, it explodes with the energy of 10 octillion nuclear bombs, releasing shockwaves, blasting heavy elements into the void. Without supernovae, there would be no gold, no iron, no earth. They're not just powerful. They're responsible for every breath you take. And just when you think that's the pinnacle, along comes a gamma-ray burst, the most energetic explosion known to science. A single burst can unleash more energy in 10 seconds than our sun.